Hello, everybody. I am head of School of Chemical and Bioprocess Engineering at UCD. I've prepared a short presentation for you to get an overview of some of our programs. It's quite short, but I'll go through it. Chemical engineering in UCD has been around since the 1950s. And we've grown and evolved in tandem, I suppose, with industrial development in Ireland and globally as well. Many of our graduates go into the process industries, broadly defined. Back in my day, a lot of people went into oil and gas, but there's a huge change now globally in terms of where the process industries are going, becoming more diverse. So an increasing number of our graduates going into the pharmaceutical sector, the biotech sector, but also into the areas broadly around sustainability, net zero technologies, and energy. I suppose the more modern sense of the energy industry, whereas traditionally chemical engineering as a discipline evolved over 100 years ago to the oil and gas industry, but as a discipline, it has broadened out. And I suppose probably for us, a large number of our graduates are now going into the pharmaceutical industry. So in response to that, we've created some relatively new programs. Probably 10 or 15 years ago, first started developing a dedicated master's program in biopharmaceutical engineering. We've had for probably 10 years now an MNJC in chemical engineering that complements our existing undergraduate program in chemical engineering. And more recently, as of this year, we've launched a professional certificate in the manufacturing of cell and gene therapies and vaccines. And this has been in planning for some time. And I'll, I suppose, maybe talk a little bit about that in a moment. So the pharmaceutical engineering program is, for most people, a one-year program, 90 credits involving 60 credits of taught modules and 30 credits of a project, which, depending on the student's choice, can choose to be a research project or a design project. The part-time program is quite different. In fact, many of the courses are delivered separately to the full-time program. It's mainly designed for people who are already working in full-time jobs, effectively, within the industry, regardless of what type of industry it is, but who want to upskill, let's say, within to meet, I suppose, demand for greater skills and in biopharmaceutical manufacturing. So that's a dedicated program that's really designed for people who are already working in industry. And the timetabling of the course, or the part-time version of the program, reflects that fact that people are already working, whereas the full-time program is a standard one-year full-time program on campus in UCD. Similarly, the MNJC in chemical engineering is a one-year full-time program. And, you know, while biopharmaceutical is defined specifically to provide graduates who can go into the pharmaceutical and biopharmaceutical sector, the MNJC in chemical engineering it produces graduates who have the skills to go into the process industries more broadly. We also find that students in that program often go on to do a PhD, if that's their choice. The Professional Certificate of Manufacturing of Cell and Gene Therapies and Vaccines is a new program, and we're starting off with a professional certificate, so initially a small program, and in future years we may look at expanding that out into a master's program, but not just yet. There is strong overlap between that and the biopharmaceutical engineering program. People who do the biopharmaceutical engineering program still will get exposure to modules and courses and material that's in this area as well. I suppose it's considered that big area of future development within modern medicine will be in cell and gene therapies, complementing existing areas. In Ireland, for example, a lot of manufacturing facilities exist, producing things like monoclonal antibodies and therapeutic proteins. But complex molecules to manufacture, quite expensive products. And of course, there is the complexity of that manufacturing process means that the industry needs highly skilled engineers, both in terms of manufacturing, optimization, and indeed the design of such facilities as well. So some of our graduates will go into different parts of that industry. There's a wide range of types of job people can get once they've done one of these programs. So that's a brief overview of some of the programs. Just briefly about the school. School is the largest in Ireland, largest chemical engineering school in Ireland, and we're ranked #1 in Ireland in the QS subject rankings. And we're highly ranked, I suppose, internationally as well, certainly within Europe. Producing graduates over 65 years, there is a network of graduates, and many of our graduates, for example, are working in obviously working in industry in Ireland, and the interaction we have with them is very important to us. That these graduates facilitate and help us in various ways. So, for example, we have a few modules where we bring in some guest lecturers from industry, not to do too much teaching, but to do a little bit of flavor, particularly around areas like design. But also some other areas as well. Our graduates go into an industry that where there's good employment, very good employment prospects in the process industries broadly, but I suppose specifically within biopharmaceutical, but not exclusively so. There are other opportunities outside of the pharmaceutical. Sometimes we forget about that, given the huge growth in biopharma in Ireland. There are still plenty of other jobs, and indeed internationally as well, for graduates who want to see opportunities open internationally as well. One of the features about our school that I'd want to highlight, makes us different, I think, makes us stand out, is that we're very research active. All of the academics within our school are working at the forefront of research and innovation within chemical and bioprocess engineering. Students who take our programs, whatever type of program we take, most programs will have a research project. Typically, certainly our master's programs will have a research project. Some may choose to do a design project instead, but a lot will do a research project. And the students, therefore, will get exposure to globally recognized and award-winning research and innovation. I would argue at the forefront of this area internationally. Certainly within many of the areas we specialize in, we would be a significant force internationally in working at the forefront of research and innovation in bioprocess engineering. And we're growing that, and we're expanding that area, those areas, and providing good opportunities for students on taught programs to get access to that world-class research and innovation expertise as part of their program. And it really is very, very important. It certainly is a very useful thing for students when they're looking for a job, to be able to talk about those sort of things. And even for some students who might move on to do a PhD, it's a very good foundation for that too. So just briefly to finish, just to keep talking, I don't want to say that there's no other industry in Ireland, but pharmaceutical and biopharmaceutical is a huge percentage of the process industries in Ireland, and it's rapidly growing, and it's constantly looking for more and more graduates. And they have many people in the industry have come to me and said, we need more people with the right skills. So we're trying to respond to that. We can't, take in an infinite number of students and produce an infinite number of graduates in this area. We have constraints, but the opportunities are very much there. Ireland is one of the world's leading manufacturer of pharmaceuticals and biopharmaceuticals, and is second only to the United States currently in terms of manufacturing these products. It's resulted in very significant capital investment by these companies in Ireland. Many of them are, quite a large percentage, are within an hour of Dublin, in the outer ring of Dublin, or within an hour or so of Dublin, particularly in the biopharma area. Significant investment in R&D as well, increasingly so. And UCD interacts with those companies. So, for example, we have an industry-based PhD students who are UCD students, but are actually based in companies. And it's now considered to be the majority of Irish exports are biopharmaceuticals, something of the order of 60% by value of goods of Irish exports are in this sector. So it's hugely important to Ireland. And, you know, it means that the companies that are see this Ireland as a global hub now for biopharmaceutical manufacturing. So we expect these companies that are here to continue to grow and provide employment for graduates of ours. So I think that's more or less it. I've talked briefly about our programs, briefly about the school, and briefly about the industry sector where a fairly high percentage of our graduates go to work. So I'll stop sharing maybe my slideshow now.
Great, thank you very much, Owen. I think that was a nice whistle-stop tour through your school and also the programs available within your school. I think our attendees would have found it very useful and maybe insightful, and hopefully some of our attendees have either made an application to us or thinking about making an application to us for one of those particular programs. So just to say again from the start, if you have any questions, please type them in using the Q&A button at the bottom of your screen there. We'll answer as many of them as we can, but maybe Owen, I'll just throw some to you. I know we always get asked at these types of events, and that our students are our potential students are kind of wanting to know about. So you kind of talked about, obviously the biopharmaceutical industry is a huge one for graduates of these particular programs. Do you find graduates are well placed to go into this area when they finish their degree, and do they have the skills necessary to get employment in those particular areas?
Yeah, I mean, we're constantly talking to industry. We want to understand what industry is looking for, and that's been at the forefront of our department, our school, since the very beginning of when we set up in the 1950s, and we constantly adapted our programs and our offerings and our courses to understand what skills people need and will need in the future. It's not just a matter of what they need now, but looking ahead. Our graduates, you know, they're mostly what you might call young people, but they'll be going into jobs that, you know, into a sector which, you know, will be evolving. You know, some of the areas we've talked about are areas where there's a lot of change, new discoveries, new products being invented and discovered. And just take the example of mRNA technology, which is at the core of a lot of the vaccines that have been developed to respond to COVID. But that technology and technology that underpins that is now seen as a new platform technology for a whole range of new medical products. So that's an area where we actually have expertise in the school. The fact that we're research intensive means that we have people within our school who are experts in that area and can translate that to the courses that they teach, and therefore pass that on to the graduates.
Yeah, I think it's good for attendees and people who tune in at a later date to know that the programs are evolving, that they change based on demand or what's kind of needed by graduates in the industry. So I think that's really important. And obviously biopharmaceutical is a huge industry, but one of our attendees just asking about maybe what are the other areas that graduates have gone into from these programs in the past, and was working in energy and the environmental sectors, and if students have gone into that.
So so people who do the biopharmaceutical engineering program tend to go to work in that industry, but people who do the MNJC and chemical engineering tend to go into the other areas, the non-pharmaceutical areas. But it's quite a common question. Like I was talking to our students, our final year students there a few weeks ago, and I was asking them, well, actually I was talking to them, I was also talking to them a year ago as well, to a different group of students. And it's remarkable how interested they are in the energy area, the modern energy area, areas around sustainability and clean energy. So there's a huge interest in that area, and we certainly do include material. We have, I think within our school, I think about slightly more than 50% of our staff are doing their research in pharmaceutical, but there's probably the other big areas for us are energy and the environment and materials and materials engineering, particularly materials engineering that supports the energy and environmental area. And that expertise is part of, or rather is translated through the courses that we teach in those areas. So there's huge interest in it, even though many of our students are really interested in it. Some of them choose to go into the biopharmaceutical industry. Sometimes at the end of the day, when jobs are offered, they will often choose the job with the highest salary and whatever about their interests. But, a good engineering qualification from UCD does open up a lot of opportunities, a lot of horizons. So you're not necessarily, but I would say certainly that the biopharmaceutical courses are very much specific to that industry. If you probably are interested in the energy and environmental area, I would consider the other program, the chemical engineering program.
Yeah, okay, I think it's good though that there's options and there's variety in there, even though, as you said, most are leaning towards biopharmaceutical, and that's potentially where jobs and money and stuff is, but I think there's other options available, which is good to know. So obviously research projects and thesis and dissertations are big parts of our programs. Do students get choice in the subjects that they do? Do they get help in choosing? Is there, that are set out for them, and is there opportunity for industry collaboration as far as those projects go as well?
Yeah, so first of all, our full-time biopharmaceutical students have a choice first between a design project and a research project, and if they choose a research project, then they get a choice of topics that are given to them or proposed to them by researchers, by professors in the area, I suppose. And they have a good choice, and they have the opportunity to ask questions and interact with the professors, to find out a bit more about it and maybe even tailor the project to their particular interests. In terms of industry interaction, yes. So in a slightly indirect way. So the projects that we do, a huge percentage of the research that goes on in our school has an industry relationship to it. So, for example, many of our research projects are funded by SFI research centres, and SFI Research, that's Science Foundation Ireland. And those research centres are co-funded by industry, typically 1/3 from industry and 2/3 from the Irish state. Now, the research is often very much fundamental research and cutting edge research, but the industry are willing to put money into that. So it means that also that the professors who are doing this research are communicating with industry partners and are making sure that the research that they're doing is relevant to industry, even if it doesn't mean that industry is telling the professors what research to do. We're not in the business, generally speaking, of doing a contract research within the university. We generally don't do research on behalf of industry. We do research that's funded by industry, but it's quite open and quite open to the freedom to work on research that is cutting edge and is more about solving the problems of the future rather than trying to solve the day-to-day issues of industry. So I think that's really important for the students to get exposure to that.
Yeah, I think that is important, and I think it's something that our potential students would find really interesting that is going on. within the school. So one or two other questions before we finish up. I just wanted to ask about maybe if you could talk about some of the career supports or some of the academic supports available to students on your programs, either from a university level or from a school level.
Career supports, yeah, I mean, the students, all of our students, no matter what they're studying or what they have access to, a very good career advice and a range of options available to them to get that advice for preparing for career planning, preparing their CVs, and preparing to be able to present themselves in the best possible way to employers, which is something that's quite important because you might be academically extremely strong and do very well, but sometimes you still have to be able to prepare yourself for an employer, and that's something the university has literally invested in. They've put in place what's needed for students to get that advice so that they're well prepared for that.
And then some of the academic supports, I don't know if you wanted to mention.
In terms of what the career?
Well, in terms of, I suppose, like if they have access to supervisors and program directors, or I know academics have open door policies and things like that, to be able to liaise.
Yeah, so from the academic support, absolutely. You know, we're back to normal now in terms of COVID, and students, you know, our programs are face-to-face programs, and we certainly have this, I suppose you might call it an open door policy. It doesn't mean the door is physically always open, but we have never, as a school, as a department, ever had any issues with, you know, with students complaining that they didn't have access to the academic staff where they needed support and help. So we you know, so it's very important to us that students feel that they can get the support and help they need if they're having any kind of difficulty, be it academic or otherwise.
Yeah, and I feel you're one of the smaller schools of engineering that we have within the college, but it means that your staff are very friendly, approachable, and then they really care about their students, which I think is important for potential students to know about. And I think the last question we might finish on, Owen, if that's okay, is if you wanted to mention a little bit about the facilities that students can have access to as part of these particular programs within your school.
Yeah, I suppose just from a teaching point of view, we're in a modern, with modern facilities and modern buildings. But I suppose when it goes beyond just classroom teaching, laboratories. So on our biopharmaceutical program, our students are expected to do. Last year wasn't great for COVID, but now that it's back to normal, students had access to the National Institute of Bioprocess Research and Training for laboratory teaching. So it's a state-of-the-art facility, globally recognized as a leading center, one of the world's leading centers for training. And it's right beside us. It's a few hundred meters away from our building. And it's an incredible resource to have nearby. And our students on the biopharma programs get access to that for laboratory. For other research projects, for example, and for within the chemical engineering program, students may do a research project, and the research project varies depending on whether it's theoretical or experimental. If it's experimental, they will often work in a laboratory. People like myself would have a research group with a team of postdoctoral and PhD researchers, and so we would often take in these students to do a research project, so they have access not just to good facilities but also good support as well, and guidance on a day-to-day basis from researchers in modern facilities, in whatever area they choose. And as I said earlier, students have a good degree of choice in terms of what type of project they do, tailored to their own interests. And I would say in terms of in terms of facilities for those projects, we is state of the art within UCD.
So I think we might wrap it up there. We've kind of run over just by a few minutes, which is not too bad. So there, thank you, Professor Casey, for your presentation today, and thank you for attendees for tuning in, and have a good rest of your day.